Hello, my name is Craig Otto, and this is Statistics for SPC, Operational Excellence. And I wanted to take a quick minute. This is not something that the students would be tested on, but I wanted to make sure that everyone understands that statistics are not um, set in stone. What I mean by that is, even though there's a 1 out of 2 chance, like for example, you go to Vegas. Um, you have red and black, and I realize there's double zeros, but in general you have red and black, and the probability of getting a red is 1 out of 2, and the probability of getting a black is 1 out of 2. Well, just because the probability is 1 out of 2, that does not mean that you're always going to have 50% black and 50% red. For example, I've been to Vegas many times, and you play roulette, and you might get, I've seen already, they had 16 black rolled in a row. Well, the probability of that is just, it's unreal. It's not, you would say it's not possible, but it happens. And we have to understand that these statistics are only estimations. They're estimates of trying to help people make decisions based on the data that we have available. And I wanted to point out that a lot of times in industry you'll hear things called confidence intervals, or maybe you might be in a job and your boss will say, well, I want to know what number will give me 95% confidence. And I wanted to kind of point that out, that in this particular example, if we look here towards the center of the screen, on screen 1 it says a Z interval. And what they're doing is, let's say you have some data available. You think that the mean is actually 12.5. Well, if you want a confidence level of how good that 12.5 is, you have to know how many samples. In this case, you had 38 samples. You need to know a standard deviation of that 12.5. In this case, it's 2.8. So when you type that in and 95% confidence, it actually spits out what's called a Z interval. And what that means is, with 95% confidence, your mean is somewhere between 11.61 and 13.39. See, that 12.5 is only the best estimate of the mean, whereas this kind of gives you, hey, with 95% confidence, you know that your mean will fall between 11.61 and 13.39. So that's a little bit, it's taking it a step further. Rather than just saying, well, that's my mean, and going with that, we can kind of calculate what's my interval. And in this case, it's kind of tight. In other words, the mean and your confidence intervals are pretty close. If you look at the next example, and in this case they had actual data, but their mean was 9.4, but look how big their interval is. It's from 3.7 to 15.1. That's a wide range for that mean to fall between. So in that case, I'd be very wary of the fact that my mean is 9.4. Yes, that's true. But how confident am I that it's truly 9.4? Not really a whole lot. Because with 95% confidence, it's going to fall between 3 and 15. That's a large range for that to fall into. So the point of this lesson, again, we're not going to be tested on this, but I want to make sure everyone is aware that statistics are not definites. They're only estimations. They're there to help us make a logical decision, and we just got to know what the data is not telling us as much as what it is telling us. I'll say that one more time. We have to listen to what the data is not telling us before we consider what it is telling us. Like in this example here, it's not telling us that your mean is 9.4 no matter what. It's not what it says. In this case, it's far from that. It could be anywhere from 3 to 15. That's a huge range. Okay, so that's a tool that we have, confidence intervals. If you are interested, I'll post this PDF on Angel so that you can kind of read down through it, maybe go through a couple examples. But I just want to make sure everyone's aware of it.